history of Babylonian mathematics, or Babylonian mathematics development. 1. Development in history of Babylonian mathematics. Babylonian mathematics is all mathematics developed by the Mesopotamians, now known as Iraq, from the beginning of Sumer to the beginning of Hellenistic civilization. Named Babylonian mathematics because of the Babylonian region's primary role as a place to study, and in age of the Hellenistic civilization, Babylonian mathematics combined with Greek and Athenian mathematics to give rise to Greek mathematics. Then, under the Islamic Caliphate, Mesopotamia, especially Baghdad, once again became an important center for study of Islamic mathematics. Contrary to the scarcity of sources of Athenian mathematics, knowledge of Babylonian mathematics was derived from more than 4,000 clay tablets excavated since the 1815s. Most of the known clay tables date from 1800 to 1600 before century and cover topics of fraction, algebra, quadratic, and cubic equation. And the calculation of regular numbers, multiplication in fours and twin primes. The slabs also includes a multiplication table and solution method, linear equation, and quadratic equation. The Babylonian plate 7 to 89 before century gives an approximation to 2, which is accurate to 5 decimal place. Second, Babylonian number system. The Babylonian number writing system was known as cuneiform, from the word kuneos, which means slice or split, and the word forma, which means form. Babylonian writing and numerals are often referred to as cuneiform because they are shaped like nails. The Babylonians wrote cuneiform using an elongated triangular shaped stick or triangular prism by pressing it against a wet clay plate to produce a tapered triangular depression resembling a nail. Unlike those of the Athenian, Greeks, and Romans, the Babylonian numerals use a correct place value system, in which the number written in the left column represents the largest value. The Babylonian civilization in Mesopotamia replaced of the Sumerian and Akkadian civilization. In the form of numbers used, the Babylonians inherit the idea from the Sumerians, namely the sexagemal number system, base 60. Due to the Babylonian prominence in astronomy, the 60-base system of calculation is still in use today. It is proved by the derivation of the number 60 seconds for 1 minute and 60 minutes for 1 hour. The reason why the number 60 is used is because this number is the smallest number that can be divided by the first 6 digits, namely 1, 2, 3, 4, 5, and 6. Another reason is that the number system most widely used by humans today is the decimal system, which is a system based on 10. The Babylonian wrote cuneiform using an elongated triangular shaped stick or triangular prism by pressing it against a wet clay slab to produce a point hollow like a nail. The following is an example writing symbols for the Babylonian numeration system, namely the Babylonians used 1 to represent 1, 2 to represent 2, 3 to 3, so on, up to 9. However, they tend to arrange symbols into neat piles. Once they got to 10, there were too many symbols, so they turned to make different symbols. 11 is 10 and 1, 12 is 10 and 2, 12 is 10 and 10, and for symbol 60, it seems exactly the same as symbol 1. 61 is a combination of the symbol 60 and 1, which therefore looks like 1 and so on. The next subchapter is advantage and disadvantage of Babylonian number system. First, advantage of Babylonian number system. First, recognize building form. Second, determination of square root value. Third, has demonstrated the Pythagorean theory. Fourth, measure an area and volume. And the next one is disadvantage of Babylonian number system. First, don't know zero. Second, not familiar when it comes to make decimal numbers. Third, don't know the negative signs. And the last one, addition, subtraction, multiplication, and division are still unclear. The next one is subchapter 4. Invention related to Babylonian mathematics. First, in geometry fact. Geometry was used by the Babylonians from 1600 before century. They calculate the circumference of a circle using 3 times the diameter. The area of the circle is used 1/12 of the square of the circumference with equal to 3,14. The volume of an upright cylinder is calculated by multiplying the area of the base by the height. The next one is algebra field. Around 2000 years before century, the development of algebra is not only able to solve quadratic equation, but also discusses solving third and fourth power equation. It can be seen that there is a relic in the form of tablets whose contents are in the form of tablets of squares and cubes of number 1 to 30 and combination of N3 and N2. The next one is in sexagesimal numbers or base 16 numbers. Babylonian mathematics was written using the sexagesimal number system or base 60 because of its superiority in the field of astronomy. The 60-based calculation system still exists today, namely by reducing the use of number 60 seconds for 1 minute and 60 minutes for 1 hour. The weakness of this system is that there is no zero symbol. The symbol 1 and 60 are the same. In this case, the space bar will also not able to help explain whether the symbol is 1 or 60. The next subchapter is legacy of Babylonian mathematical history. The cuneiform script was used in the manufacture of Babylonian letters. The plates are written while still wet and then dried or burnt. There were 4 blackboards found, namely, first, Yale YBC 7289 board. The Yale YBC 7289 board is a board on which a diagram is drawn in the shape of a rectangle measuring 30. The Yale manuscript contains N3 plus N2 tables for solving equation, including cubic equation that lead to simultaneous equation leading to quadratic equation. The next one is Plimpton 322. Plimpton 322 is a board number 322 which is the result of processing ancient Mesopotamian manuscript written by J.A. Plimpton containing mathematical problems. The manuscript contains a mathematical table from the period between 1900 until 1600 before century. The Plimpton 322 manuscript is in the form of a table consisting of 4 columns and 15 rows containing Pythagorean triple number. The next board is Susa board. Now, this board shows how to calculate the radius of a circle through an equilateral triangle. In this Susa board, there is a third triangle ABC, which the center of the circle point O, and there is a line AD connecting point A which line BC. From the figure, we can see that triangle ABD is a triangle on the right side of a circle. So, by using Pythagorean formula can be obtained. AB square plus BD square is equal to AD square. So, AD is 40. Then it will be concluded that the radius of the circles is x. So, OB is equal to OA is equal to x. The next one is Debye tailboard. Now, this Debye board displays a geometric problem that asks for the dimension of a square whose the diagonal are known. The next subchapter is Babylonian mathematical figures. First figure is King Sargon. Now, King Sargon was the leader of Akkadian nation. In terms of culture, the Akkadian imitated the advanced Sumerian culture, so that a new culture was developed called the Sumerian Akkadian culture or acculturation. At this time, found the calculator abacus. Nah, abacus is used to, in bahasa we say tunanetra, anak tunanetra. Next one is King Hammurabi. Nah, King Hammurabi was the greatest Babylonian king. King Hammurabi is famous as a legislator. It is thought that in the past, the laws that were issued were made into charters in the form of inscriptions and shown to the general public for approval. So, laws are made by the government solely to suit its own opinion. In this sense, the charter made by King Hammurabi, commonly known as the Hammurabi Charter, can be considered a precursor to the official legal system, and it is currently in effect in modern society. The next one is Diopantus. Diopantus is the father of algebra for Babylonians, who developed the concept of Babylonians algebra. A Greek mathematician living in Alexandria. Diopantus' major work is in the form of a book of arithmetic, the first written book of algebraic system. The preserved portion of Diopantus' arithmetic contains the solution of approximately 130 problems that yield first-order equation. The next one is Babylonian scientists. Now, Babylonian scientists discovered the determination of the value of the square root and even demonstrate the Pythagorean theory long before Pythagoras himself came up with his theory, and this was proven by Dennis Ramsay, who translated an ancient record dating from 1900 before century. The next figure is Otto Neugebauer and F. Theorio Dangin. Now, Otto and Theorio found much knowledge about the contents of these mathematical tablets no older than 1935. Since the work on interpreting these tables is still ongoing, new and equally interesting discoveries are very likely in the near future. The next one is Grotefend. Now, Grotefend tried to solve the puzzle that in 1347 Rawlinson perfected the result of Grotefend. The tables turned out to be about all the stages and interests of the life of his time and cover many epochs of Babylonian history. I think that's all that I can explain about chapter 5, Babylonian mathematics development. Please forgive me if I have a mistake, and I hope I will be better in the next chapter. Thank you.